Let's review some essential vocabulary for Unit 2. First of all, notice how your chart is organized. On the left side, all of these terms are terms that you will be tested on. These will be on the test, meaning you have to know how to do them, what they mean. The terms that are on the right side of your chart are needed to know, but not specifically for the test. Okay, but you do need to know those. So let's start with midpoint. Remember, midpoint is, first of all, a point. Think of mid, so in the middle. So you're going to be finding averages of the 2 points that are given, averaging the x's and the y's. So capital M for the point that represents the midpoint is when you are averaging the x's, adding them, dividing by 2, and averaging the y's, adding them, dividing by 2. Distance, also known as length, hence why they are next to each other. Distance and length, basically interchangeable, the same thing. When we calculate a distance, we think of the difference between points. And if we need to use a formula for distance, the formula involves subtracting the x coordinates and subtracting the y coordinates. However, if you're looking on a graph, another way to look at it is like when you're counting rise and run for slope, and you just square those values. So we can take the difference and then square it, or we can count the rise and the run and then square them. But don't forget about adding and taking the square root. Length is simply a measure of distance between 2 points. And if we needed to find length, we can measure it through a variety of devices or use the distance formula when it's on a graph. So perhaps we think when graphing, use the distance formula. Now the distance formula is really just an extension of the Pythagorean theorem. Pythagorean theorem we know for right triangles, where the sides of the legs of the right triangle are A and B, and the hypotenuse is C, and it's C squared equals A squared plus B squared. Well, when we're using it in a graph to find length or distance between 2 points, the hypotenuse is usually our distance between the points, that slanted segment. Sometimes it's vertical, sometimes it's horizontal, but those can be counted. When it's slanted and we're finding that distance, we're doing the square root of the rise squared plus the run squared, just like in the distance formula. Same thing. Congruent segments. Segments that have the same length. Now, if they have the same length, that might mean AB, segment AB, has a length of 10, and segment BC has a length of 10. Notice how we write them as just point A to point B, distance being 10. But if we say they're congruent, segment AB with a segment hat, congruent symbol, segment BC, like that. Congruent angles, similar to congruent segments, but these are angles that have the same measure. Angles that have the same measure are congruent angles. So we might say the measure of angle GHI equals 20 degrees, and the measure of angle KLM also equals 20 degrees. That's telling us they have the same measure. How we can write it then is that angle GHI is congruent to angle KLM. Segment bisector. Anything, basically, a point, a line, a ray, that intersects a segment Remember, intersect means crosses, intersects a segment at its midpoint. Maybe you draw yourself a picture to have a visual about what that looks like. Know how to use your compass and your straight edge to make the segment bisector. So I'm going to find the midpoint, and I'm going to say this half is congruent to this half, and then I'm going to draw the segment bisector by drawing any sort of line or ray or plane that crosses the segment at its midpoint. Know how to do this, or construct this with a compass and a straight edge. Check out the notes on constructions if you need an extra hint. Perpendicular bisector, now we're still bisecting like the segment bisector, but we're doing it at a right angle. So we can say that's going to be a line, a ray, or a segment that bisects a segment at a 90-degree or a right angle. Let's draw a picture of what that looks like. There's a segment, just like the previous picture. Bisect, find the midpoint, cut this in half, but now we must do it at a right angle. See how I made that have a 90-degree angle? This line is now a perpendicular bisector of the segment. An angle bisector. Again, bisect, cut in half, but this time do it to an angle. A line, a ray, or a segment that cuts an angle into two congruent angles. So two angles that will measure the same size. So let's draw an angle. I'm going to draw it with two rays. There's an angle, and now I'm going to show the angle being bisected, so this half and this half are the same. I bisected this angle with a ray. This ray is bisecting that big angle. Perpendicular lines. Lines that intersect at a 90-degree or a right angle. Draw yourself a picture of perpendicular lines. Make the right angle, arrows to show they go on forever. Complementary angles. These are two angles that add up to 90 degrees. Supplementary angles are two angles that add up to 180 degrees. They can be adjacent, but they don't have to be. For example, the measure of angle ABC equals 30 degrees. Its supplement would be angle DEG. Notice they don't share any points, but that would be 150 degrees. Those two angles are supplementary because they add up to 180 degrees. 30 plus 150 equals 180. Complementary angles add up to 90. So those would be two angles like 40 degrees and 50 degrees, for example. A linear pair are supplementary angles that are also adjacent. Think of the word line and pair. Pair means that there are two, and they make a line together. So making a line, I can create two angles. So remember that a linear pair, they're supplementary, they're adjacent. So this angle right here might measure 100 degrees. What does that mean about this angle that's right next to it? These angles that share a side? That's right, it has to be 80 degrees. Why? Because both of them together make this line, this straight angle that has to be 180 degrees put together. Another type of angle pair that's made by intersecting lines, vertical angles. If we draw some intersecting lines, the vertical angles are the ones across from each other. Vertical we usually think of as up and down, verticals up and down. So we can think of these two angles, these obtuse angles across from each other, they're vertical, they will be congruent. These angles across from each other, they're vertical, they're congruent. So think of it as, first of all, vertical angles are made by intersecting lines, their sides being opposite rays. They are congruent and easy to identify because they are across from each other. Finally, two postulates that are very useful in remembering: segment addition postulate and angle addition postulate. What does that mean? Well, let's take a segment, and along that segment I'm going to put a point. So let's call the segment with endpoints A and B, and the point that I put somewhere between A and B, we'll call it C. Well, if I were to measure AC and know how long that was, let's say it's just 5 units of some sort, and then I were to measure CB, let's say it's 2 units, well, what does that mean about the entire length of segment AB? That's right, 7 units. How did we do that? We added the 2 smaller segments next to each other to make the one long segment. So how can we describe that? 2 smaller segments, addition, add to make the longer segment. And how do we write that with symbols? We've got little segment AC, that's 5, and we can add it to the little segment next to it, that is 2, called CB, and all together it equals the long segment from A all the way to B. That's our segment addition postulate. Angle addition postulate, very similar, but with angles. Let's draw a big angle. Let's label this angle GHI. In the interior of the angle, we'll put a point. Interior of the angle, we'll put a point. Let's call that point K. And let's draw a ray that connects H to K, so ray HK. That creates 2 different angles. We have this little angle right here, GHK, this one that might be 20 degrees, and then we have the little angle next to it, KHI, this angle right here that's obviously in my picture not 20 degrees, maybe it's about 50 degrees. And we put them together to make this larger angle, GHI, and we can do that because they are adjacent. And together, how much do they make? 70 degrees. How do we know that? Because that little angle, 20 degrees, plus the angle next to it, 50 degrees. Together they make the bigger angle of 70 degrees. How do we write that with our angle measures? Well, the big angle that we're making is called GHI. See how I trace it? So that's the measure of angle GHI. And that equals what 2 angles put together? This smaller angle, GHK. I'm saying the measure of that angle, GHK, and the angle that's adjacent to it, KHI. Measure of angle KHI. So just like segments, 2 smaller angles, so very much like the segments, but we're adding 2 small angles, add, right, add to make the larger angle.